Welcome to the Explainer. Hey, if you've ever written a program, poured your heart into it, closed it, and then reopened it only to find everything you did just vanished into thin air, well, you're in exactly the right place. Today, we're tackling the solution to that huge headache, file handling.
Okay, so let's set the scene. Picture this. You've been coding for hours. You've made this awesome program. Maybe it's a game that keeps track of your highest score, or a to-do list app to organize your life. And it works. It's perfect. So you close it down, feeling pretty good about yourself. But then you come back the next day, you fire it up, and nothing. The high score is gone. The to-do list is blank. It's like it never even happened.
So has that ever happened to you? It is so frustrating, right? And your first thought is probably, something's broken. I have a bug. But what if I told you that's not a bug at all? In fact, your computer is doing exactly what it's supposed to do.
Yeah, the real culprit here is your computer's main workspace. It's RAM. Now, RAM is amazing. It's super fast, which is why it's perfect for running programs in real time. But it has this one key characteristic. It's volatile. And all that really means is that it's temporary. Any information you store in there is gone the second the power gets cut. The program closes, the power goes out, and poof, memory wiped clean.
So if we can't rely on that temporary workspace, what's the fix? How do we make our programs actually remember things between sessions? Well, this is where the hero of our story makes its entrance, the power to save our data permanently. And the tool we use for that is the good old file. A file is really just that. It's a collection of data that a program saves so it can be used again later. This is how we make sure our high scores and our to-do lists are still there when we come back. And this slide really breaks it down, you know? On one side, you've got RAM. It's fast, but it's totally forgetful. It's volatile. And on the other side, you've got files, which are non-volatile. That just means the data is safely on your hard drive, ready for you later, even if you restart the whole machine. The bottom line is simple. When you save to a file, your data is safe and sound.
Okay, so we know why we need files, but how do we actually use them in our code? It might sound kind of intimidating, but lucky for us, there's a really simple universal logic that works in pretty much any programming language you can think of.
And here it is. It's basically a simple three-step dance. First, you open the file. Think of it like pulling a specific notebook off a shelf. Second, you act on it. This just means you either write new stuff into the notebook or you read what's already in there. And third, and this is the step people always forget, you close it. This saves all your changes and puts the notebook back on the shelf, all neat and tidy for next time.
Now let's see how a programmer might sketch this out before writing any real code. This right here is called pseudocode. It's like writing out the recipe in plain English before you start cooking. And look, you can see those same 3 steps we just talked about. Open my file, then some action like write file or read file, and you guessed it, close file. It's the perfect game plan.
All right, we've got our blueprint. We know the plan. Now let's see what it looks like to turn that plan into actual working code. We're going to look at how this exact logic works in a super popular language, Python.
And this is where the magic happens. On the left, there's our plain English pseudocode, and on the right, that's the real Python code that does the exact same thing. Just look at how it maps over. Our plan to open my file for write becomes the Python command myfile equals open mytext.txt. The idea to write file becomes the myfile.write function. And that super important final step, close file, becomes myfile.close. See, it's the exact same open act close logic, just using Python-specific words.
And just to really drive this point home, let's circle back to this quote. I mean, it doesn't get any clearer than that, does it? The entire reason we do any of this, the whole purpose of learning file handling, is so our data can be stored permanently. No more vanishing high scores. You are now in control.
So think about it. In just a few minutes, we've gone from a really common programming problem to its elegant, super powerful solution. We've seen the plan, we've seen the code, so the real question is, what are you going to do with this new superpower?
Let's just do a quick recap of the essentials, the things you absolutely have to remember. First, your computer's RAM is temporary. It's forgetful. Second, files are your best friend for storing data permanently. Third, the logic is always that simple 3-step combo. Open, act, and close. And finally, number 4, this isn't just some neat trick. It's a fundamental skill for any programmer. You're going to use this all the time.
You literally now have the key to making programs that can remember things, that can save a game's progress, that can log important events, that can store user settings, and a million other things. This one simple concept opens the door to so much more. So I'll leave you with this to think about. Now that you know how to save data, what amazing things will you build?